Alright, let's dive in Chapter 3, Machine Learning. It consists of several parts. Part 1, what's the machine learning? Part 2, machine learning models. Part 3, machine learning methods. Part 4, application of machine learning. The last one, case study, error species recognition. Let's start with part 1. What's the machine learning? First of all, I have a question for you all. You must have eaten watermelon before, right? So, how do you pick a ripe one? You may say, tap on it, listen for the crapper sound, or check if the stem is straight or curly, or see which one has a green outer skin. You use this method to judge. Now, how do you choose watermelon this way? Let's think. You may say it's based on experiments. Exactly, many effective human judgments are made based on past accumulated experiments. By using experiments, we can make effective judgments in new situations. So, can artificial intelligence, like humans, continuously learn from experiments, using the learned result to make effective judgments in new situations, and possess similar thinking ability as humans? The answer is yes. Artificial intelligence can also learn from experiments and continuously think. For example, Siri is very popular. It's intelligent voice assistant on Apple phones. The next, AlphaGo, the AI AlphaGo program, and it's very popular. Current very popular language model, ChatGPT. These agents possess thinking abilities similar to humans. So, how do these agents acquire this thinking ability? That's what we're going to learn today, machine learning. By now, you might have guessed it. Agents simulate and achieve human learning through intelligent learning. Through machine learning, agents can continuously learn new knowledge and experiments, enabling them to continuously progress. So, what's the machine learning? How about its definition? Okay, machine learning is a discipline. It started how computers can simulate or realize human learning behavior to acquire new knowledge or skills, recognize the existing knowledge structure, and continuously improve their performance. Next, let's further understand what the machine learning is through an interesting video.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Okay, welcome back. After watching the video, we learned that machine learning is the core technology of artificial intelligence and one of the fundamental ways to equip our computers with intelligence. Machine learning has been applied to various approaches to artificial intelligence, such as natural language processing, pattern recognition, machine vision, and intelligent robots. These academic terms may still be unfamiliar to you, but I will introduce them in detail in subsequent lessons. For now, just get a general impression. So, how does agents actually learn through machine learning? Okay, put simply, our computers use an algorithm to discover and learn the laws contained in historic data, thereby generating corresponding models. Then, by inputting new data into these models, predictions and corresponding conclusions can be drawn. I mentioned earlier that algorithms are used to generate models, which generally requires providing data to the artificial intelligence agents. Thus, the agents use this data, proceed through the algorithm to generate the model. So, let's think, what kind of data needs to be provided to agents? Let's take a look. The data used in machine learning consists of three parts: features, feature value, and labels. Let's understand the composition of data through a table. How many data entries are there in this table? Obviously, there are two. First, let's think what the features of the data are. Before we continue, let's take a short break.